So now we have all of our things that we're gonna be using in a cup, which we'll just scoop a little spoonful in each of these. And in each of these is half a cup of water and then 1 teaspoon each of our pH indicator that we got going right here.
Okay, now we're gonna pour each of our items inside our. Oh my god!
No way! I
Okay,
didn't think something was
sorry.
gonna
I
happen.
just get excited. Sorry.
Science! What?
Oh.
What?
Okay.
Oh my
I'm
gosh.
gonna chill. Okay.
Okay, and then
Let's go. Alright.
so we already did our vinegar and we did the
Orange juice.
orange juice. This is just regular water, right, Franny?
Yeah.
Okay. We'll do a little bit more. And this is the sink water that we have here at the dorms. Next we have,
Seawater.
oh yeah.
Mm.
Okay, but if we think about it, seawater is supposed to be alkaline. So that makes sense. That makes sense.
And now
It should be that
baking
color.
soda.
I guess this is supposed to be on the alkaline side. Oh, that's kind of like a blue, like a pretty blue one. Just a
Like
little
it's
more.
greenish.
And then since we didn't have ammonia,
We use soda.
I don't know if this will do anything. Oh,
Oh, okay, I'm so
So
excited
that was-
right now. Oh my god, look at all the different colors. Okay, sorry, but I'm excited right now. All different colors right here.
I think that if we would have had ammonia, then it probably would have been an even darker blue.
Yeah.
But I guess soda,
That's the
carbonated
best we
soda, is
got.
very acidic, right?
Yeah.
Because that's what we're trying to get at. So this is the acidic side, starting with
Acidic
vinegar.
side, yeah.
And
Finish
then,
with water.
and this is supposed to be alkaline. So baking soda is very alkaline. Soda, we're just gonna disregard that, whatever.
Here.
So in this, the handout, they say that the water should be neutral. So this is a neutral color. Here, yeah. We'll get this paper and do it like this.
Yeah, I'm gonna do it.
And then acidic, somewhat acidic. Then, oh wait, no, that's, okay. Acidic, neutral, somewhat alkaline, somewhat more alkaline. Okay, so now me and Franny, we have straws. And we are going to use our straws. And we're going to set a timer. We'll be back after this, but we're gonna set a timer for 1 minute
Yeah.
or more and blow into each of these with our straws. See what happens.
Now that we have blown for 2 minutes air in the cups with the straws, this is the result. The straw in the cup. I think that these 3 acidic are way more pink and like it looks more pink instead of the other ones. Yeah, they.
Yeah, that's good, yeah. So it just pretty much says, compare the color of the liquids in the 2 cups.
Yeah. So, and for answering my 2 questions, okay. In your words, explain the
Wait,
process of this.
hold on.
Okay, so after we blew in each of them with the straws, I think that like between our indicator, I think that these are way more pink than the actual like pH indicator. And so yeah, they are like pink, light pink, and like very light pink, almost purple, the acidic ones. And so now I'm answering the 2 questions. So the first one was, say in your words, explain the process of the ocean acidification. Okay, basically the ocean acidification is caused by the chemical reaction between CO2 and water, and that makes carbon acid and release nitrogen. Yes, the ion that is H plus. And so the 30% of carbon dioxide stay in the ocean. And so as CO2 increase over the time, we have the ocean acidification. And yes, these affects also the food chain, the life like in the ocean, like all the like sea animals. And so yes, I'm concerned about the acidification because it doesn't only affect, like we said, the ocean, but also like the food chain is also our economy.
So, in my own words, I was asked to explain what the process of ocean acidification is, and give you guys the cause and effects. So, CO2 in the atmosphere is being trapped into the ocean, and to be approximate, 30% is getting trapped from the atmosphere into the ocean. Because of that, the CO2 collides or interacts with the H2O, which is the water, creating a reaction or chemical reaction we'll go with chemical reaction, whatever, of HCO, which is, what was that, bicarbonate? HCO, which is bicarbonate, and then it also creates H+. So bicarbonate and hydrogen are the result of the CO2 and the H2O interacting into the ocean. This results in an increase of pH and a decrease, no, vice versa, whatever, sorry. I'm a bad public speaker, but I'm trying. That means that it is going to be a decrease in pH and an increase in acidity. Let's see. So the causes and damage of this would be the sea life being affected by this increase of acidity. The acidity would decrease the percentages of bicarbonate and calcium, and that's bad for the sea life, such as coral, Great Barrier Reefs, and shellfish of any kind. So like crustaceans like shrimp, krill, I think they're called, crab, lobster. We even discussed in one of the videos the sea butterfly, which is a shell creature. All of these would be affected by the process of ocean acidity. I think that was the term. So yeah. And then I'm concerned for this because if the acidity is going to keep increasing in the ocean, that's going to cause a lot of these crustaceans to overall go extinct because they're not going to be able to produce the calcium. They're not going to be able to produce the shells that they need because they won't have the calcium needed to make those shells to live, and or even let those shells be recycled, I guess. And if these crustaceans or creatures go extinct, then it messes up the whole food chain, which means that bigger fish like tuna and salmon, things that we commonly fish for, would completely decrease as well because they're starving to death. And as a result of that, that would in fact affect our economy because people would be out of a job because they don't have any fish to go catch. People wouldn't be buying it, so there'd be less money going into the economy. And in the end, even if we don't want to discuss it with in terms of money, it's just the overall threat to all sea life. So here we have the more acidic side, and then we work our way to alkaline. This is our indicator, our pH indicator, which was boiled cabbage. What we did was we had a cup of water, and then we put in, or maybe it was a half cup, I forgot. It was a cup? Yeah, a cup of water, and then we used 1 teaspoon to scoop in some of that indicator, and then mixed it with some of these products. After blowing into a straw of these, with a straw in these cups for 1 to 2 minutes, we notice that there is a change that occurs. This is like a bright pink in comparison to this, which is very dark purple. And then this is kind of pink, and then this is like a very neutral, which is a kind of expected and makes me feel a little bit better because this is the dorm's water from the sink. And then this is almost like a cooler purple, and this is from the seawater. So that just shows how alkaline it should be. But if things were to keep going in the negative way, our seawater would probably be something more like this.
Yeah.
And then this is extremely alkaline, which is our baking soda water.